Let's take a look at acid-base conjugate pairs. It says acids and bases don't always have to take the normal format. They can look different. It says most of the time we use Bronsted-Lowry's theory to define acids or bases. If it loses an H plus, it's an acid, and if it gains an H plus, it's a base. That's the best way for us to find out if something's an acid or a base. Now we need to know what it looks like after it has gained or lost that proton. So that's going to give us something that we call conjugate pairs. And we have conjugate bases and conjugate acids. And the conjugate pair is going to be the original base and its conjugate acid, or the original acid and its conjugate base. So let's go ahead and take a look at these individual definitions. It says a conjugate base is what's left of the acid after it donates a proton. So, for instance, if I were to have HCl, okay, HCl is going to donate its proton, and I'm going to end up with a hydronium ion and a chloride ion. Well, the question becomes, what does HCl look like after the H is gone? Well, remember, it's not just an H. A proton is an H plus. So not only are we losing a hydrogen, we're also losing a positive charge as well. So this is going to be just Cl minus when it's over with. So if HCl is the acid, Cl minus is the conjugate base. A conjugate acid, it says what the base or reactant becomes after it has accepted a proton. So let's take a look at, let's see here, what's a base we can use? Let's look at NH3. NH3. So after this accepts a proton, it's going to not only gain the proton, but it's also going to gain the positive charge. And so this is going to end up being NH4 plus. And so now this was the base. Now this is my conjugate acid. So let's go ahead and keep going here. All right. So we want to take a look at these examples and identify the acid, the base, the conjugate base, and the conjugate acid. So the first thing I need to do is I need to understand that my reactants are always going to be my acid and my base, and my products are always going to be the conjugates. So I want to take a look at these, and I want to see who lost a proton and who gained a proton, okay? So I like to call acids my losers, okay? Acids lose protons, therefore acids are losers. So when I look at this H2O and I look over here at OH minus, I can tell that H2O is my acid because it lost a proton to become OH minus. So if this is my acid, OH minus has to be my conjugate base. Well, the proton that was lost went to this phosphate ion. Okay, so that means that this accepts a proton. After it accepts the proton from water, it now becomes HPO4 2 minus. Okay, don't forget it not only gains an H, it also gains a positive charge, taking it from -3 to -2. So that means that this was my base and this was my conjugate acid. Go ahead and pause the video for a moment and see if you can figure out this next one on your own. All right, so welcome back. We have H3PO4 that turns into H2PO4 minus. So I know that this little fellow right here lost a proton to look like this. I know acids are losers, so that means that this is an acid, and this is my conjugate base. HSO4 minus gains a proton, so it's going to be my base, making H2SO4 the conjugate acid. All right, let's keep going. When I take a look at this next example, it wants me to determine the conjugate acid for the following bases. Well, remember, bases are going to gain a proton. So if NH3 gains a proton, remember, I'm going to draw a proton over here. Is that it? No, it is H plus. I'm not only gaining an H, I'm also gaining a positive charge. So for NH3, when I gain a proton, I have NH. Well, if I gain a proton, it goes from 3 to 4, and I also gain a positive charge. Okay, take a look at a sulfate ion. Remember, this is a sulfate ion right here. SO4 2 minus. Well, if I gain a proton, then I'm going to put an H out front. I still have SO4. But now instead of 2 minus, now it's just 1 minus because I also gained a positive charge that's going to cancel out one of those negative charges. Let's look at water. H2O. If H2O gains a proton, it is going to look like this. It's now going to be a hydronium ion, H3O plus. Let's look at this next graph, and it talks about these acids, and it wants us to determine the conjugate base. Remember, acids are losers, so since an acid is a loser, it's going to lose a proton. Here's your proton, so it's going to lose an H and a positive charge. So NH3 is going to go down to NH2 minus. Nitric acid is HNO3. HNO3, if it loses its H, now it's just NO3. It also loses the plus charge, it's now minus. And water can also act as an acid. Check this out. Water can act as a base or as an acid. So if water is acting as an acid and it loses a proton, its conjugate base is going to be OH minus. So now we can briefly take a look at this last chart. I'm going to have you do most of this on your own. It gives you a few situations here and wants to know if this is the conjugate acid, what's the conjugate base? Well, if this is my conjugate acid, I know that bases have to gain protons. Well, if this had to gain a proton to become this, it had to start off as F minus, making F minus my base and HF my conjugate acid. If my conjugate base is a bicarbonate ion, which looks like this, HCO3 minus, my acid had to lose a proton in order to become this. So that means I had another hydrogen to begin with, and I had a neutral charge. So that would make my acid H2CO3. Okay, obviously, if I only know the base and the conjugate acid, I don't fill in the acid and conjugate base for that. I could have a number of acids react with F minus to make this. So you're only filling in the appropriate thing that you can fill in for this. Go ahead and take a look at the rest of this on your own. We'll take a look at it in class.